Today we're going to talk about how we can use the Pythagorean theorem. So the Pythagorean theorem states that if a triangle is a right triangle, then a squared plus b squared equals c squared will help us find the side lengths of that triangle. Well, the converse of the Pythagorean theorem, the converse meaning kind of the opposite, is also true. The converse says if the equation a squared plus b squared equals c squared is true or works for the side lengths of a regular triangle, then we can make the assumption that it is also a right triangle. So this is important for a lot of cases. When we get any kind of three sides of a triangle, whether we have a picture or not, whether we are told there's a right angle or not, we can use the Pythagorean theorem if we know the three sides to prove if it is a right triangle or not. I want to remind you that the hypotenuse is always the longest side of any right triangle, and that is what we use for the C value. That is important, especially when you are given three side lengths of a triangle and not given a picture. The longest side is always the C or the hypotenuse. So let's look at how that works. So here with the first one for letter A, we have a right, we don't know if we have a right, we have a triangle where we are given all three sides, but what we don't know is if this is a right triangle. Now I know that's the angle we're actually looking at, not really because it looks like it, but because if I look at my three different sides, the C has to be the 25 because it is the longest of the sides, which would make 24 the A or the B, and the 7 the other A or the B. So by the converse of the Pythagorean theorem, I should be able to take this 24 and square it, add 7 squared, and I should be able to get 25 squared if this is a right triangle. But we don't know that that's true. I run through 24 squared is 576, 7 squared is a 49, 25 squared is 625. Well, as this one turns out, 625 is what the left side equals, which tells me that this definitely is a right triangle because the Pythagorean theorem does work with those side lengths, which also then tells me that if I was trying to go further with this, I know that the angle in the corner that we were first questioning about is definitely a 90-degree right angle. So here in this triangle, again, I want to make sure I'm careful about my sides. The 90 has to be the C because it's the longest side. The A and the B are really not as important, but that's what they are. So when I go to plug this one in, I'm going to get 40 squared plus 80 squared equals, we hope, 90 squared. If I square each of these, I get 1600 plus 80, I'm sorry, not 80. 80 squared is not 80, so 80 squared is 6400 equals 8100. Now in this case we get 8,000 equals 8,100, which is obviously not true. So they are not equal. And that would just basically mean that this is not a right triangle. Okay? So that was the converse of the Pythagorean theorem. We can determine if something is a right triangle if we're given the three sides, just by simply plugging in the formula a squared plus b squared equals c squared, and if the formula works, then we can say that it's a right triangle. The other thing that we're going to talk about in this section is the distance formula. Now, we've actually already worked with the distance formula when you did your water park project. The distance formula helps us find the distance between 2 points, and basically what it is using is the Pythagorean theorem. It is basically taking a distance between two different points, like you might see here on this graph, and kind of creating a right triangle with our vertical distance down and then our horizontal distance across, which is now forming a right angle, and then using the Pythagorean theorem to kind of find the hypotenuse, or the d distance that we're looking for. So the formula we are using is involving the y2 minus y1 for our vertical, the x2 minus x1 for our horizontal. We're squaring those two, and then we're adding them together. That would give us d squared, but then when we take the square root of both sides to get d squared down to d, that's when we get the formula that you see here. So the distance formula is one that definitely is something that's a little more complicated and hard to figure out. Basically what you're doing is you're subtracting your x's and squaring that number. You're subtracting your y's, squaring that number, adding those two things together, and then taking the square root. We obviously would only be interested in the positive square root because we wouldn't look at a distance as a negative, even though we would have two square roots for these numbers, positive and a negative. We would throw out the negative and only keep the positive. So here, let's practice the distance formula. So for the distance formula, we basically said we have the distance equals the radical sign in its x2 minus x1 squared plus y2 minus y1 squared. Now, when we did the slope formula, we had to make sure that we went in the exact same order between our x-coordinates and our y-coordinates when we subtracted, or else we were going to get different answers. You don't have to worry about this one as much, because no matter what I do, whichever order I subtract my x's and my y's, as soon as you square it, if it was a negative answer, it's now positive, and if it was a positive answer, it's still positive because of how the square works. So it's not as critical that you keep them in the same order. Might not be a bad idea just to keep in that practice so that when you're working with slope, you don't all of a sudden trip yourself up thinking, oh, it doesn't matter. It doesn't matter in the distance formula, but it might not be a bad idea just to kind of keep thinking the same thing so that you go in the same order. So in this one, I'm going to do the square root. I'm going to subtract my x's. So all I'm going to do is I'm basically going to take my negative 3 and subtract 2. Subtract 2, square it, and then I'm going to take my 5 and subtract negative 1. And I got to make sure that that negative 1 stays in parentheses, because we know that the 5 minus a negative 1 is what we're looking for, not just 5 minus 1, which is a different answer. So I move on to the next piece. I'm going to take the square root, and I'm going to do negative 3 minus 2 is negative 5. I want the parentheses around that to make sure I get negative 5 squared, and then I'm going to get a 6 and square that. The distance again is going to be 25, that's not a good 25, plus 36. Then we get the square root of 61. Now again, this is where our calculator comes in. And we know that even though we would get 2 square roots for this, distance would never be as a negative number. So we're going to use our calculators, and we're going to say that our answer is approximately 7.81 units is the distance for right now. We don't really know what our distance is referring to as far as a scale, so distance is approximately 7.81. So here we have another situation for example 3. Where we're trying to design a football play, where the player who is running down the field makes a 90-degree turn and runs to the corner of the end zone. Basically, what we're trying to find out is from where you started to where you ended, we want to kind of see how far of a distance did you run, and did they run a 90-degree turn. So here's what we want to think about. So we've got several different things going on here. So what we have is if they do a 90-degree run, then that would tell us that we would have a right angle. So what we want to do is we want to think about what is the distance between each of these, because we have a right triangle, we can use the Pythagorean theorem. But at the moment we don't have our distances, so we actually have quite a bit of work to do. So what I'm going to do is I'm going to start with distance 1, which is right up here to start our first part. what I'm going to do is plug in what we have. I'm going to do 60 minus 30, square that number, and then I'm going to add 50 minus 20 and square that number. So that's going to then, once I start simplifying, give me 30 squared plus another 30 squared, (900) plus 900, D1 equals 1800. Now, I'm going to leave this just like this before I do the square root button on the calculator. And there's a couple of reasons that I might do that. For now, I'm going to do it because I don't really need to know what it is yet. And anytime I'm going to hit the square root, I'm going to have to do some approximating and some estimating. And at the moment, the best answer I have is the square root of 1800. And as soon as I hit the calculator, if it's not a perfect square, which it's not, I'm going to get a crazy decimal, and then I'm adding it to other crazy decimals possibly. So for now, I'm just going to leave it like that. I'm then going to move on to the distance down here. So we're going to call this one D2. So D2, I'm going to, again, big radical sign here, so I have some room. I'm going to subtract my coordinates. I'm going to take the 30 and the 80, and I think I'll probably just go 80 minus 30 to keep it positive. Not that it really should matter. And then I'm going to look at negative 30 minus 20. And again, you'll notice that I'm keeping it in the same x2 minus x1 and y2 minus y1, but like I said, you really don't have to. I think it's just a habit to get into so that you don't kind of make the mistake once you get into a real slope problem. So 80 minus 30 is 50 squared. Negative 30 minus 20 is negative 50 squared. So D2 is going to be the square root of 2500 plus 2500. So D2 is going to be the square root of 5000. And again, just like with D1, I'm going to leave it just the way it is for now, and we're just going to keep moving on. Well, as you can obviously see, we have a lot of work still to do here, and we don't have a lot of room left over. I'm going to keep moving this up a little bit, and I'll have to kind of keep bouncing back and forth, I guess. So next we're going to look at D3. So once I move over to the D3 side, see if I can fit this in, but this isn't right as nice and small as a regular pen or pencil. D3, again, when I start subtracting my numbers, I'm first going to focus on my x's. So I get 80 minus 60 squared, and then I'm going to do negative 30 minus 50 squared. I just made it. D3 is the square root of 20 squared, negative 80 squared, D3 400 plus 6400. D3 is the square root of 6800. So again, I'm leaving all those the way they are for now, just so that we don't have to look at approximating things and figuring that kind of stuff out. So what do we have so far? We have a bunch of numbers that don't really tell us anything, except that it tells us how far apart each of these things were that happened. From our starting point of our play, we ran down to the square root of 1800 feet away to do a cut into the back of the end zone. Then we ran another square root of 5000, and from the start to the end part, we were 6800 and the square root of that away. But what does that really mean? We are still trying to figure out if this was a 90-degree right turn. Well, this is where I can now go and use my Pythagorean theorem and the converse of the Pythagorean theorem. Remember, the Pythagorean theorem basically says if I take a squared plus b squared equals c squared and it works, then it would be a right angle. Now, looking at my three distances, D3 is the longest distance, so D3 has to be my C value. And what that means is, if I square D1 and I add it to D2 squared, it should equal. So here's where that works. So D1, we said, was the square root of 1800. So we square that. D2 was the square root of 5,000, and we square that. D3 we said was the square root of 6,800, and we square that. Well, from previous chapters and previous knowledge, remember what we've talked about is the square and square roots undo each other. And how that's going to help me here is that when I look at the square root of 1800 and I square it, basically what I'm saying is the square root of 1800 times the square root of 1800, which is going to simply leave me with 1800. When I then move on to the next one, the square root of 5,000 times the square root of 5,000 gives me 5,000. And on the other side, the square root of 6,800 times the square root of 6,800 is going to give me 6,800. So the opposite of each other, the inverse, is going to undo each other to give me what we started at. And now you can hopefully see that by approximating things, we would have gotten some numbers that would have been really close, but they probably wouldn't have come out to be exactly this because we would have had to do some rounding. But if I finish this off and I add those two things together, I get 6,800 equals 6,800. So by the converse of the Pythagorean theorem, what that is going to then tell us, so we can give our final answer, is yes, he made a 90-degree cut at the 20-yard line. And again, we know that not because the picture looks like it, and you got to be careful about that. The temptation is to say, well, yeah, it looks like a 90-degree angle, so yeah, it is. We want to be able to prove it, and mathematically we just did. By finding the distances of each of those legs, we were then able to figure out if the converse of the Pythagorean theorem worked.